Okay, so on Friday, on May 4th, in business calculus, we talked about a little bit. We got this section started. We talked about elasticity of demand. This will be the last section that we cover before the exam, and we began class with a quiz, so we really only got through the beginning of example 3. So let me go through that and get us all the way up to at least defining the elasticity of demand, and then at least doing an example calculating an elasticity and also interpreting what that quantity represents. Okay. Alright, so before defining and calculating elasticity of demand, I want to pose a question and then define what is called the relative rate of change. So suppose a broker is trying to tell you two stocks. Okay, one for a company called Intech and then one stock for a company called Globex. The broker estimates that the price per share of Intech is $200 per share and increasing by $4 per year, and that the price per share of Globex is $50 per share and increasing by $2 per year. So what that means is if you buy one share of Intech, get a color here, so that's $200 per share, and we know that it's increasing by $4 per year. So if you buy that share for $200, after 1 year, that the value of that share would increase to $204. And the price per share of Globex, that's $50 per share and increasing by a value of $2 per year. Okay, so you buy one of these Globex shares at $50. After the end of 1 year, it would increase by $2. So you'd have your share would be worth $52. The question is, which stock is the better buy? Now, just by thinking about maybe the fact that Intech is $200 per share and increases by $4 per year, well, imagine or just think about what Globex is $50 a share. If you buy 4 of those, right, that would give you you'd be able to buy 4 shares of Globex for the price of 1 share of Intech. But when you purchase 4 Globex shares, at the end of the year, each one of those shares is going to increase by $2. So that's really telling me that total, if I spend $200 and buy 4 shares of Globex, that $200 investment is really going to grow by $8 per year. So just thinking of it that way, Globex is the better buy. But we can actually, without having to do any of that calculating or reasoning, we can define what's called a relative or percent rate of change. Okay, so definition. There's two forms of each of these, but first of all, the relative rate of change of a function f of x, or a quantity, so the relative rate of change of a quantity. For example, we could talk about the relative rate of change of the value per share, or the value of the stocks, is the derivative f prime of x divided by f of x. So right here, that's your relative rate of change. And if you multiply that quantity by 100, you get what's called the percent rate of change. Okay, so again, basically this is saying how much is the quantity changing relative to the value of that quantity itself. Okay, so for Intech, if you look at the bottom here, example 1, I've made this little table that's got the 2 companies. We're going to have the relative rate of change per share, and then we have the percent rate of change per share. Okay. Although ultimately the units just end up being dollars. And let me explain that here in just a moment. Okay, so first, Intech, the rate of change of Intech is $4 per year. Okay, but you're going to have to divide by the value of the share, and that ends up being 0.02 if I'm not mistaken. Or if you multiply that by 100, that's going to be a 2% rate of change. Okay, so that essentially what that means is if you were going to buy any Intech shares, for every dollar you spend after a year, or any amount of money that you spend, your investment's going to grow by 2% of that value. Okay, now Globex, the relative rate of change here is, well, the rate of change is $2, that's thinking derivatives, rate of change in the numerator, divided by the quantity or the value of the each share, and that'll give you 0.04 or a 4% rate of change. Okay, so any investment you make with Globex, you're going to see a 4% return on that investment. Okay, so it turns out Globex, using this relative rate of change approach, would also tell us that it is the better buy. We should definitely buy Globex stocks. Any amount of money that we're going to spend, you would get a higher return on the Globex stock. Okay, so now let's take some function f of x, x squared minus 2x. We're going to find the relative rate of change when x is equal to 10, and then we'll round that quantity to 3 decimal places. I don't have my calculator on me right now, so I might not be able to do the rounding part of this, but I'll do the best that I can. Okay, so the relative rate of change of f of x is going to be, well, okay, so now let's do an example. We're going to find the relative rate of change of f of x equals x squared minus 2x when x equals 10. Okay, so first, the relative rate of change of f of x is the derivative divided by the value of f of x itself, which in this case the derivative is going to be 2x minus 2, and then we divide by the original function. And there's no need to factor here. The numerator and denominator aren't going to share any common factors. And when x equals 10, the relative rate of change is, well, it's going to be 2 times 10 minus 2 over 10 squared minus 2 times 10, which equals, in the numerator you have 20 minus 2, which is 18, and in the denominator you have 100 minus 20, which is 80. So if I divide top and bottom by 2, I think I get 9/40. Okay, so that's the relative rate of change of the function when x is equal to 10. So again, what it tells you is, there might be some sort of units on your function, but if you increase the input x by 1 unit, you can expect that it's going to increase by 9/40, okay, per unit time. Okay, so again, that's just telling you relatively the rate at which the function is increasing relative to itself. Okay, I think this is just an example of calculating a relative rate of change for a function. I think the application makes much more sense, like my answering that first question I posed, or doing the first example, where we're working with a quantity. In that case, it was the amount of dollars per share, and then we had the rates at which those quantities were increasing. Okay, and then we have an interpretation there. The relative rate of change is going to tell us, at what rate or what percentage is any investment going to grow every year. Okay, so now that we have a relative rate of change, we are ready to define what the elasticity of demand is. Okay, so sorry for the pause there. Now let's read the definition first before we look at what the formula ought to be. So what you do is you let the price be P and the demand X. Okay, so the elasticity of demand, we're going to have two variables. We have the price P, we have the demand X, and and this is the price and demand for a product, and they're going to be related by a price-demand equation of the form X equals F of P. So that's telling us the demand is a function of the price per unit. And then the elasticity of demand at a price of P dollars, the elasticity of demand at a price P is going to be the function E of P, that's for elasticity at the price P. And it's the negative, so pay attention here, there's a negative sign. Okay, but it's the relative rate of change of demand divided by the relative rate of change of price. Okay, so, and notice it's a function of P. The elasticity is a function of P. So the price is a function of P, and then so is the demand. And we're going to do the relative rate of change of demand divided by the relative rate of change of the price. Okay, so what I'll do is we'll derive the formula here. So E of P, the elasticity at price P dollars. There's a negative sign out front. I can talk about the why there ought to be a negative sign out there. Usually, the relative rate of change of demand ends up being a negative quantity because as the price increases, the demand will decrease. Okay, so the minus out front is to take care of the negative relative rate of change of demand. So it ensures that our elasticity is always a positive quantity. Certainly only in the cases where demand is decreasing, which is typically the case. Okay, so it's going to be minus, and then it's going to be the fraction. In the numerator, we have the relative rate of change of demand. Remember, I'll write it over here, but the demand is the function f of p. So we're going to have f prime of p divided by f of p. So that's the derivative of the demand function divided by the demand function. And then in the denominator, okay, since the price is just P dollars, right, price equals P, the relative rate of change of price would be the derivative, which is 1, so the derivative with respect to P over the function P itself. And when you, instead of dividing by 1 over P, if you multiply by the reciprocal, the formula for elasticity becomes minus P times F prime of P over F of P. Okay, so that is what so you're going to have the demand function. You'll be able to find its derivative, multiply by P, divide by the demand function, and just make sure you have that negative out front. Okay, so at the bottom of that page, okay, we have theorem 1. If the price and demand are related by x equals f of p. Oops, my bad. If the price and demand are related by x equals f of p, we just said the elasticity of demand at a price of p dollars is minus p f prime of p over the demand function f of p. Okay? Alright, or sometimes if you like, you can write minus px prime over x, right? Because x prime is just another notation for f prime of p, the derivative of the demand function. One thing I should mention is the elasticity is supposed to be a measure of how sensitive the demand is to changes in price. Okay, so essentially what the elasticity is going to tell us is maybe you want to increase your price. We'll be able to tell, so if we increase the price by a certain percentage, we'll be able to tell how much the demand, what percentage the demand is going to decrease by. So one note you want to make to yourself here, then we'll do our next example, is that if, and this is a general fact, if the price P increases by R%, then demand decreases by R times the elasticity at P%. And generally, this idea could be used to tell you essentially if you would want to increase your price a certain amount, and then by doing that you'll be able to use the elasticity to know if your revenue is going to increase. Okay. So you'd take more money in. So for instance, say you increase your price by 10%, but the demand, say, decreases by 5%, that's going to be a case but where that 10% price increase will actually lead to an increase in revenue. We didn't get a chance to fully explore that idea in class on Friday, but I will inform everybody in class on Monday of those consequences of when to use the elasticity to determine if a small change in price leads to an increase in revenue or a decrease in revenue. Okay, but quick, let's do one example here that I did in class. I'll assume a percentage increase in price, and then I will find the corresponding decrease in the demand. Okay, so this is about as far as I got in class. We did an example. So suppose the price and demand for a product are related by this equation, price-demand equation, x plus 400p equals 8,000. We're going to find the elasticity of demand, E of p, and we're going to calculate and interpret the following, starting with E of 4. And we only calculated E of 4 yesterday. I wasn't able to actually do the other values, so we'll finish that on Monday. Now, first, what you have to do is you have to solve the demand equation for x. So you'll get x equals 8,000, and you can subtract the 400p to the right-hand side. That is going to be your demand function f of p. And then the formula for elasticity at a price p dollars is going to be minus p times, and then we'll also divide, but it's going to be minus p times the derivative of x, or f prime of p, which is just negative 400, divided by the original demand function, 8,000 minus 400p. And in the numerator, if you multiply that negative in, you'll get p times 400, or 400p, over 8,000 minus 400p. And then I believe in class, if you calculate the elasticity at $4, you get 400 times 4 divided by 8,000 minus 400 times 4. And let's see if I can do this. I believe we get like 1,600 over 8,000 minus 1,600, which is 6,400, and we got 0.025. So there's the elasticity at a price of $4. And then let me suppose a certain so when the price is $4 now, we'll look at a particular percent increase in price, and we will find the corresponding percent decrease in demand. Okay, so we just found that E of 4 is 0.025. Okay. Now I'm just making this number up, but if we assume the price P